Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P2A00, pertains to a malfunction in the air-fuel AF sensor 1 circuit, indicating a range or performance problem. AF sensors are crucial components in managing the combustion process by monitoring the air-to-fuel ratio in the exhaust system. This particular sensor helps ensure that the engine operates efficiently, reducing emissions and maintaining fuel economy. In the context of the Honda Civic models from 2011 to 2015, the AF sensor 1 is located before the catalytic converter, vital in providing precise readings for optimal engine management. Troubleshooting this issue is essential, as it can lead to decreased performance and increased emissions if not addressed. Accurate diagnosis and timely repairs are critical for maintaining the overall health and efficiency of the vehicle. The error associated with DTC P2A00 indicates a problem with AF sensor 1, which plays an instrumental role in measuring the air-to-fuel mixture entering the combustion chamber. Located before the catalytic converter, this advanced sensor helps ensure the engine operates within optimal parameters. By relaying data to the Engine Control Module, ECM, it aids in fine-tuning fuel injection and timing, thereby supporting overall engine performance and efficiency. If the AF ratio deviates from the expected range, it can cause several performance issues, including poor fuel economy and higher emissions. This sensor's failure may also trigger the check engine light, alerting the driver to potential issues. Understanding the location and function of AF sensor 1 is essential for effective troubleshooting efforts in this specific diagnosis. Several factors can contribute to DTC P2A00, with the most common being a faulty AF sensor 1. Its primary function is to accurately measure the air-fuel mixture. If it fails, the ECM may receive incorrect data, affecting engine performance. Additionally, poor connections or loose terminals at the AF sensor or the ECM can lead to intermittent failures, causing improper readings. Wiring issues, such as frayed wires or corrosion, can significantly impair the sensor's ability to function correctly. Regular maintenance checks can help identify these potential issues early on. Addressing these possible causes ensures the reliable operation of the vehicle's emissions and performance systems, making it critical to verify the integrity of connections and circuitry during troubleshooting. When encountering DTC P2A00, several symptoms often become apparent. One of the most significant is poor fuel economy, as the incorrect air-fuel mixture impacts combustion efficiency. Drivers may notice reduced acceleration and overall engine performance issues, including rough idling and decreased responsiveness. Additionally, the check engine light is likely to illuminate, serving as a warning of the underlying problem. If left untreated, these symptoms might exacerbate, leading to more severe engine issues, elevated emissions, and costly repairs. The symptoms emphasize the importance of timely diagnosis and addressing any potential faults related to the A-fuel sensor. Monitoring these signs can lead to quicker identification of DTC P2A00, helping prevent further complications. The first troubleshooting step for DTC P2A00 involves turning the ignition switch to the on position, which powers up the electrical systems without starting the engine. Following this, use the Honda Diagnostics System HDS to clear the existing DTC, which allows for a clean slate when testing the system's functionality. Once the DTC has been cleared, start the engine and maintain a steady engine speed of 3,000 RPM without any load. This step is crucial as it allows the engine to reach operating conditions, and ensures that the radiator fan engages, which helps stabilize engine temperatures during testing. It sets the stage for further diagnostics by confirming that the AF sensor responds adequately under these controlled conditions. For the second step of troubleshooting DTC P2A00, it is essential to perform a test drive under specified conditions to evaluate the vehicle's performance and gather data. Begin by ensuring that the engine coolant temperature monitored by the Engine Coolant Temperature ECT Sensor 1 exceeds 158 degrees Fahrenheit or 70 degrees Celsius. This ensures that the engine is operating within its designed temperature range. Additionally, for automatic transmissions, AT, the vehicle should be in drive, and for manual transmissions, MT, it should be in third gear. The vehicle speed must be maintained between 25 to 55 miles per hour for 5 minutes, as this period allows the AF sensor to get a good reading during varied engine loads. After stabilizing at steady speeds of 55 to 75 miles per hour for another 10 seconds, decelerate with the throttle fully closed for at least 4 seconds, ensuring the sensor can report back accurate readings during various driving conditions. After completing the test drive, the next critical step involves monitoring the onboard diagnostics (OBD) status using the Honda Diagnostic System HDS for DTC P2A00. This data will indicate whether the system has failed or passed the diagnostic checks. If the HDS indicates failed, it confirms an issue with the A/F sensor. In this case, replacement of the A/F sensor 1 is necessary to restore correct functionality. If the HDS indicates passed, the system is temporarily operating correctly, but it's crucial to check electrical connections for any loose terminals or poor connections at both the A/F sensor and the Engine Control Module, ECM, or Powertrain Control Module, PCM. Any existing intermittent failures should be noted and monitored continuously. If the HDS indicates executing or out of condition, keep driving until a definitive result is obtained. The fourth troubleshooting step involves performing a repair verification to ensure that any fixes applied have effectively resolved the issue. Begin by turning the ignition switch to on, and then resetting the Engine Control Module, ECM, or Powertrain Control Module, PCM, using the HDS. This reset is essential as it clears any previous fault codes stored in the ECM and prepares the system to relearn optimal idle conditions that may have been disrupted due to the sensor issue. Following the reset, conduct the ECM PCM idle learn procedure to recalibrate necessary parameters. Then, repeat the test drive under the same specified conditions again to gather comprehensive data on sensor performance. Typifying proper execution of the tests will reveal the health of the AF sensor 1 in the OBD status, confirming whether troubleshooting measures were successful. The final troubleshooting step involves a thorough monitoring of the OBD status using the HDS to determine the results of the preceding steps. If the HDS indicates passed, it signifies successful resolution of the DTC P2A00 issues, fulfilling normal operating parameters without any current faults present. If failed, it suggests that the problem persists, calling for a review of the entire diagnostic process, starting from the initial conditions. Conditions classified as executing indicate that further driving is necessary to obtain a valid status update, while out of condition means that specific parameters were not met during the test drive, necessitating re-examination of the conditions to reconfirm sensor functionality. Understanding these potential outcomes is vital for ensuring the system's reliability before concluding the troubleshooting process. Upon concluding the troubleshooting process for DTC P2A00, final repair verification is crucial for ascertaining that the problem has been effectively resolved. The first step involves rechecking all DTCs using the HDS to confirm that no new diagnostic trouble codes have emerged following the repairs. Successful repairs will be reflected by the absence of pending or confirmed DTCs related to the AF sensor. Before finalizing the repair process, ensure thorough documentation of all maintenance actions and test results. These records are essential for future reference and tracking of the vehicle's health, potentially presenting insights into recurring issues. Conducting a thorough final verification not only guarantees quality repairs, but also enhances the reliability of the vehicle moving forward. Preventive maintenance plays a pivotal role in mitigating the recurrence of issues indicated by DTC P2A00 and ensuring the optimal functionality of the vehicle's emission system. Regular inspections of all AF sensors and related electrical connections can help uncover any early signs of wear or malfunction. Periodic checks should also include looking for corroded or loose terminals, which can significantly affect sensor performance and cause erroneous readings. Another essential aspect of preventive maintenance is monitoring the overall vehicle performance, which includes observing fuel economy and throttle responsiveness. By staying vigilant with these practices, potential issues can be identified and addressed promptly, minimizing the need for more extensive repairs in the future. This proactive approach supports ongoing vehicle safety, reliability, and overall efficiency. In summary, DTC P2A00 signifies a performance or range issue with the AF Sensor 1, an integral component for optimal engine management in the Honda Civic models from 2011 to 2015. Troubleshooting this code involves a step-by-step process, beginning with initial checks and culminating in thorough verification of repairs. Understanding the complexities of AF sensor functionality and related symptoms is vital for accurate diagnosis. Furthermore, the role of preventive maintenance cannot be overstressed. Engaging in regular vehicle checks can preemptively address many concerns tied to this DTC. By following a structured approach to troubleshooting and maintenance, vehicle reliability, performance, and compliance with emission standards can be ensured. Please like and subscribe to the channel. See you next time!